Ahoy, mateys! Welcome to a very special edition of Code Wars Code Katas. Okay, I'm not going to talk like that the whole time because that would get really old. But hello! Welcome to Coding Garden with CJ. Today is a very special edition of Code Wars Code Katas. We have Halloween-themed problems that we're going to solve. Hello, everyone. Hello, Andrew. Welcome to the stream. Hello, Gaming But Not Really. Hello, VIP Siler. Hello, Carlos. Hello, my username is Ryder. Hello, Bob's Paradox. Hello, Abraham. Welcome to the stream. You may notice my beard beats. This took a very long time to do, and I'm very proud of it. But yes, I am a pirate. So if you're not familiar with the show, I pick Code Wars, Code Katas problems to solve and solve them live here in front of you. This GitHub repo, github.com/codinggarden/code-katas, has all of the previously solved katas, including links to the ones that I plan to solve tonight. I went on Code Wars and kind of searched for like Halloween, trick or treat. The first one's pirate themed. I only found ones that are these difficulty. If anyone can find a like a 4Q that's like Halloween or spooky themed, I'm open to doing it. Yes, I will no longer be in the Pirates of the Caribbean movies. I am now a live streamer on YouTube. Okay. The first one we're going to solve tonight is called the Pirate Code. The next one is Halloween Trick or Treat. And the last one is called Halloween Sweets. And as I mentioned, if you have a suggestion for a 4Q, it must be Halloween or spooky themed. It could be like spiders or bugs or something, I don't know. But I'm open to solving it. Cool. Let's get right into it. So the first one I'm going to do is Pirate Code. So it says to take a look at this pirate game. I watched the video, but it wasn't exactly like the problem describes. But here's the description. Give Amaro an array to confirm his logic for the next time when the number of pirates changes. Keep in mind that each time the pirates find a treasure, the amount of gold equals to the number of pirates times 20. So you get in a number of pirates, you multiply that times 20, that's how much gold you get. If the number of pirates is 2, that's 40 gold, because 2 times 20 is 40. So you return an array that says Amaro gets 40 and the other pirate gets 0. If there are 3, then Amaro gets 59, the next one gets 0, and the next one gets 1. So ultimately, the longer or the more pirates that you have to serve, you have these alternating 0s and 1s with however much gold Amaro gets at the beginning of the array. Yes, I'm a modern pirate. No DMCA here. Cool. All right, let's do this one. This is the Pirate Code. I said I wasn't going to talk like that. I'll stop talking like that. Let's create a new file. We'll call it Pirate Code. I'm going to keep saying Pirate Code like that. And we'll throw that function in there. Let's grab a few tests. Let's clear that. Throw those there. Let's make these just be console logs. And we'll fire up Quokka, which will automatically run the code in my editor. Cool. So right now, our function returns undefined. So for all test cases, we're getting back undefined. All right. Now let's talk through how we're going to do this. So we will need an array that is the length of the number of pirates. So when pirates is 2, it's length 2. When pirates is 3, it's length 3, etc. So we will need a place to store the gold. I'm going to keep talking like a pirate. Oi! James Phillips, welcome to the stream. Okay, so we need a place to store the gold, ideally an array. Then we can iterate, right? We'll need to iterate up to the number of pirates. So iterate up to the number of pirates. Okay. If this is the first iteration, we need to put the gold in the first place for Amaro. So if initial index, or like 0, then push total gold minus number of pirates into the array. So, oh, and it's not just the number of pirates. Let's think about this, because the end of the array is where we're going to need to distribute the remaining gold. So it's really going to be number of pirates minus 1, that gives us this amount, divided by 2, because that's how much gold we're going to give out. So push total gold minus number of pirates minus 1 divided by 2, and we'll probably like drop the remainder. But essentially that will give us how much gold is going to need to be distributed at the end of the array. Else, if index is odd, because this will be 1, 2, 3. So if index is odd, push a 0. Else, we'll push a 1. Cool. And after all of this, we will return the gold. Cool. Cool. Let's code it. And if you're not familiar with the stream, typically I solve these things in multiple ways. So I'll solve it probably with a for loop first, but then we'll see how we can use like higher order methods or something like that. Also, let me know how your Halloween is going. Did you dress up today? Did you go trick-or-treating? Let me know. Okay, so we need a place to store the gold. Gold, it's going to be an array. We need to iterate up to the number of pirates. So let's just do a simple for loop. It starts at 0, and it goes up to pirate num, because that's the number of pirates. Okay. Okay. Now, if this is the initial index, I guess technically, okay, we'll write it like this, but then I got another idea, but okay. So we'll say something like, if I is equal to 0, then we need to push total gold minus number of pirates minus 1 divided by 2 and drop the remainder. So let's call this like Amaro gold. And this is going to be number of pirates minus 1 divided by 2, and we drop the remainder. So we'll do a math.floor on this. Okay. And we'll push that into the gold. So gold.push Amaro gold. Cool. Else, if index is odd, so I mod, well, I think we'll check if it's even. I don't know how you check. If check it's odd if it's divisible. No, we'll check if it's even. So if I mod 2 is equal to 0, then we'll push a 1. I've kind of like flipped the logic here, but I'll say gold.push a 1. Else gold.push 0. And we flipped our logic. So we'll say if index is even, push 1. Else push 0. Okay. I think that will do it. We return the gold, and it's wrong. Oh, we have to multiply this times 20 for the total number of gold. I forgot to do that. So this will be pirate num times 20 minus 1 divided by 2. That's wrong. Let's figure this out. Okay, let's put this in a variable. Total gold is going to be pirate num times 20. Okay, that's our total gold. Now, if we take our total gold, do we subtract 1? What are we subtracting 1 for? We don't need to subtract 1 here. can figure this out. I believe in me. Okay. So we need total number of gold minus 1, because that's what's left over. Okay, so we'll say total gold minus 1. That is what is left over. And we're not going to divide that by 2. We're going to divide it by the number of pirates. No. Do we care about gold? I'll figure this out. My username is writer has a good point. First you're a pirate, but then you're returning the gold. What's going on here? You're very right. But the way this problem works out is I will be Amaro, the captain, pirate captain, and the initial index in the array is how much gold I get, and this is how much gold all of my subordinates get. So I'm still walking away with a good bit of gold. Yar-har, fiddle-dee. Some people want my gold, apparently. Okay. This math is just wrong. We need to figure it out. Okay, so in this case, there were 2 pirates left over. And we're only giving one of them gold. Okay. So I think this is actually going to be, Amaro's gold will be total gold minus this number. That's what it is. Number of pirates minus 1 divided by 2, and that's how much we're going to be giving away. That's the winner. There we go. Okay. And this works out. So Amaro, in this case, gets 98 gold, and then everyone else gets 0 or 1 gold. I think we've done it. Ooh, I like it. So there are some suggestions for what I should push into the array. Let's make sure this works on code katas, but then I'll write it like five other ways. Sample tests. Yarr! Is that what pirates say? I don't know. Okay. One thing I was thinking is, what if, so we actually don't have to start the iteration at 0. What if we started at 1, and then now all of this logic for Amaro's gold can go before it. And now we just iterate after that. And that should still work the same way. Yeah, still works. And then we could potentially use gaming but not really suggestion, which is push I plus 1 mod 2. So what's the remainder of I plus 1 divided by 2? Let's do it. So we'll say gold dot push I plus 1 mod 2. That is wrong. Because then that would be, well, for instance, 1. 1 plus 1 is 2. 2 mod 2 is 0. Okay. Then when I is 2, 2 plus 1 is 3. Mod that gives us 1. Is this happening in some weird order? There we go. I had to put that in parentheses. But I like it because this determines the remainder of the division, which is either going to be 0 or 1. I like it. Thank you very much. I mean, that seems to work. Cool. I like this. Let's try to use some higher order methods. And one thing I'm also thinking is, what if we did this in reverse, right? What if we start at the end? I guess it would be tricky, but we could start at the end and put ones in, and then by the end of it, we know how many ones we've put in, and we can calculate his gold that way. I think let's try doing that. Okay, I'm gonna write the pseudocode code for this because it'll be interesting. Let's take a quick stretch. Yarg! Okay, so we again need a place to store the gold. A place to store total gold, because we'll use that. We then need to iterate backwards. From pirate num to 0. And then we can kind of do the same logic. So if the indice is odd, 0, otherwise 1, and then we'll subtract from total gold. So let's use this math. Amount of gold for current place is that. Push and subtract from total. And actually we'll iterate backwards up to 1. And then after all of this, and it's not going to be a push, it's going to be, we need to put it, we'll say insert, because we'll have the indice so we can actually put it in the right place. And then after all of this, we know how much gold is left. So push remaining, insert remaining gold, and then return the gold. Cool. I like this one. Hello, Alka. Welcome to the stream, yarg, mateys. Hey, Dad. Welcome to the stream. And Jesus. Cool. Okay, so gold. Place to store the gold. Okay. Total gold is going to be pirate number times 20. And now we're going to iterate backwards. And it's going to be from pirate num minus 1, because we want the last indice down to 1. So we have our for loop. We'll let I equal pirate num minus 1, while I is greater than or equal to 1, because we want to go all the way down to 1. And we'll subtract 1 from I each time. And the amount is going to be this fancy logic provided by the wonderful Gaming But Not Really. So that's the amount. We'll take total gold and subtract the amount. And this should be a let, because we're modifying it. And then we insert the amount. Here we can just say gold at indice I is equal to total amount. And then after all of this, the gold in the first place is just going to be the remaining gold. In this case, total gold. Let's say remaining gold. Let's call this remaining gold. Nope, 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 nope. There we go. Return the gold. And we've done it. Cool. I like this one. This one's cool because we didn't have to do like fancy math to figure out how much goes for Amaro. We just have like a running total. I like that. Yes, Andrew Lane has the one-liner. I think I'm gonna write that now because that uses higher order methods. So this was fun. What I'm gonna do now is essentially like this one, but using higher order methods. So the Amaro plan with pirate num. So we need an array. It needs to be of a specific length, which in this case will be pirate num. And then for every value in it, we're going to we'll do a map. So we'll take this essentially empty array and we'll map it to create some values. So we get the value itself, which because we used array.from is undefined. We then get the indice, which we can use. We'll do that. And then pretty much this logic can go in here. So if I is equal to 0, we want to return total gold, which will be pirate num times 20 minus the amount of gold that we're going to be giving away. Else, we're going to return this value. Cool. And that works. Very nice. And we can write it as a one-liner, which Andrew Lane provided. Oh, I guess that's true. Array.from takes a second parameter, which is essentially a map, so we could do it all in one go. Like that. I like it. Awesome. Let's try to write this all on one line. We'll use a ternary. So we need... We're going to return I is equal to 0. So if I is equal to 0, then we need to return this god-awful thing. Else, we're going to return this thing. Oop, oop. That works. And then we could put it all on one line just like this. Nice. Catching up on the chat. I was missing some things. Oh, Amy asked, how long did the beard beads take? Like an hour? It was not easy. Yeah, putting beads in your beard is not easy at all. Cool. Cool. And hello, really Cygnus. Today is Code Katas, so I'm just solving Code Wars code problem. Code Wars Code Katas problems. Cool. That was fun. I'm going to submit this one to Code Wars. Sample tests. Attempt. We did it! Submit final. Cool. Let's see how other people did it. Some bit shifting. I don't know what this... I think it's bit shifting. 1 raised to the 1. I don't know. Some crazy stuff. Crazy. What? Why would people submit solutions like this? I mean, we could probably figure out what they're doing. This is a whole lot of like weird bit shifting and stuff like that. Bit shifting. Huh. Cool. All right. Moving right along. And for those of you that are just joining, this is a Halloween theme. So the first one I chose was pirate themed. This one is actually Halloween themed. So this one's called Halloween Trick or Treat. Okay. Halloween is coming and many children are in front of your house. They are shouting trick or treat. So you need to give them some candy. Let them leave. So you're going to get 2 arguments. Children, which is the number of children, greater than or equal to 2. And you're going to get candies, which is going to be packets of items like so. It's an array of arrays. If the children get what they want, return, thank you, strange uncle. If not, return trick or treat. How to know if the children are satisfied. 1, each child has at least 2 candies. 2, each child gets the same amount of candy. 3, no children get the bomb. I did not read this beforehand. Like that's okay. We're not giving children bombs. That's not what this is about. And 4, packets cannot be divided. Each child gets a full packet. What? All right, let's do it. It seems fairly easy. Maybe I'm not thinking of everything, but new file. Trick or treat. Have our sample test. We'll start up Qualcomm. I think the console logs are happening way over there. Yeah. So right now we're returning undefined. Okay. Let's do it. These are our test cases. So these are how we know if they're satisfied. So we have the number of children, and then we have candies, which is an array of arrays. All right. Each child has at least 2 candies. We can check that. So, first we need to check candies length is equal to number of children. Okay, if that's good, then we can check each inner array. Check each candy bag to see if greater than length 2. If so, return true. Okay, that's for that case. I think we'll write out all the logic, but then we can probably solidify it or consolidate it so it's not multiple things. Each child gets the same amount of candy. So actually, we could do that here. Well, yeah. Wait, do all 4 of these have to be satisfied? No, I think just any one of them has to be satisfied. Okay. So, I mean, I'm thinking we can do... Maybe we do this logic to begin with. Because if not, then we're immediately done. Oh, not return, but if not, then it's going to be trick or treat. Okay. Each child gets the same amount of candy, so we check each candy bag to see if same length. And we can, we'll write the code, but essentially we could like look at the first candy bag, use that as the length we're checking the rest of them for, and if they all have that length, then it's good. In this case, no children get the bomb. So check each candy bag to see if does not contain bomb. And I'm assuming this is if it's greater than 2. I think it has to satisfy all of these. We'll see. If so, return, thank you, strange uncle. Packets cannot be divided. Each child gets a full packet. I don't know what that means. Packets cannot be divided. Oh, I see. It's a restriction. You can't split up the candy in any given packet. Okay. Cool. Sanjay says, "Good morning, looking dope. I appreciate it. Yarg." Yeah, each array in the array is a packet. And so I think this is just a restriction that, like, you can't split up the packets inside of them. Okay, let's try it. So check that candy's length is equal to the number of children. So if children is equal to candy's dot length, well, it's not equal to, is greater than candy's dot length, then we're going to return trick or treat. We're immediately done because we know that we don't have enough packets. Okay. Now, let's take a quick stretch. Joe is saying, I think your plan for part 2 is wrong. Each child gets the same amount of candy. I mean, my thought is if each of these inner arrays is the same length, then it's good. Okay. Because of the candy and apple. Oh, am I supposed to differentiate between candies and apples? Let's see. Oh, I see. It's not two things, it's two candies. Okay. Check if each candy bag has at least two candies. Not just things, because kids don't like apples. That makes sense. Okay. Check each candy bag to see if same amount of candies. Okay, I see what you were saying, Joe. Thank you. Cool. I really don't know how this bomb is going to come into play. Like, is it if both of these are true, or if one of these are true, then you check for the bomb? I don't really know. Okay, let's figure it out though. So, check each candy bag has at least two candies. So, here's what I'm thinking. We can do candies dot. I'm gonna write out the higher order method logic, or should I write it? I'm gonna write it out. So we want. Wait, is every a thing? I think it's a thing. Let's look up every on Indian. Yes. A method that tests whether all elements in the array pass the test implemented by the provided function. Okay, so for every bag of candy in the candies, we want to make sure that the number of candies, so we'll say like num candies for the bag, is greater than or equal to 2. And then we'll write a quick little function called numCandies. This takes in the bag, and we can reduce it. So we're going to have the total candy and each individual thing. And if thing is equal to candy, then return total plus 1. Otherwise, return total. And the total starts off at 0. So we look at one of these inner arrays, and we're reducing it down to a number. So for each one, if it is a candy, we increase the total by 1, otherwise we don't. So that will give us the number of candies in a bag. So if every bag has at least 2 candies, then we return thank you, strange uncle. So let's throw this in a variable. So we'll say like all at least 2. And then we can check it. If all at least 2, then we'll return thank you, strange uncle. Okay. Candies? Did I spell candies wrong? There is no bomb, but maybe a bomb. Yeah, you're right. Maybe a bomb is something that only. Oh, there's a bomb. I found a bomb. Hey, Julian, welcome to the stream. Some people are saying it needs to satisfy all conditions. We'll see. Let's see. And lastly, we'll return that. Yeah, this is weird, but I can yeah, it's not totally straightforward. So this next check, we need to make sure that every bag has the same amount of candies. So what we could do is like have a variable for the number of candies in the first bag. And that's just going to be num candies at 0. And then we need to do a very similar check. So we'll say all same amount of candies. That's going to be the number of the candies in the bag is equal to number of candies in the first bag for every bag. And if that's the case, thank you, strange uncle. And then we can check if there's a bomb. I think there's going to be some holes in our logic here where we have to check for multiple. I don't know. This one's not super clear. Check it to see if anything contains a bomb. Maybe it has to be all three. Yeah, so I'm checking enough bags for all the children at the very beginning. Okay. So let's say has bomb equals candies dot sum. So sum is another higher order method that returns true if any one of them returns true. Well, we can do it on here. Returns true if at least one element in the array passes the test. So we get a bag and we'll say like has bomb. Cool. And really we can just pass in has bomb. And then we need a function called has bomb that takes in a bag of candies and we'll return bag.sum some item is equal to bomb. Oh. We'll say one has bomb. And if one of them has a bomb. No, I think this is where things get tricky because we need to know if there is no bomb and they have at least 2 candies, right? That's what I think. I don't know. We have all of these things working separately. We'll try to combine them together. So if it has a bomb, then we need to return trick or treat. Else, return thank you, strange uncle. Now there are definitely things wrong with what we have here. But let's take a step back, see what we've done, and then fix it. Okay. Can I do this? Yeah, cool. Okay, so this one is broken. We're passing back thank you, strange uncle, but we should actually return... Oh, no, that's right. We're getting thank you, strange uncle. This one is broken because we should be passing back trick or treat, but we are passing back thank you, strange uncle. Really? I think we can do this. If there's at least 2, then all of this logic needs to go in at least 2. Yeah. Yeah? Yeah. And really, we can check to see if it has a bomb first. Okay, let's go back to where we were. So I think I want to check for bombs first, because then we can end immediately. Okay, so watch me. I got this. Okay, so we have that function up there. We can say if there's not enough or it has a bomb, trick or treat. Cool. Okay, now if there's at least 2 and there wasn't a bomb, it's going to return thank you, strange uncle. If there's not at least 2, then it's immediately done. Right? That. Done. Okay. Let's catch up on the chat because I have no idea what I'm doing. Gagan asked, what keyboard are you using? It is a fairly inexpensive mechanical keyboard I found on Amazon. If you just search for like RGB mechanical keyboard, it's like less than $40. Yeah, so Joe says, can you remove the bomb packet before checking if you have enough? And I think I'm doing that now because if any of them had a bomb initially, boom, trick or treat. Cool. I don't know if I've done it yet. So this one is broken. This one should be trick or treat. This one should be trick or treat. All these 2 are broken. Why are these trick or treat? Because none of them have at least 2 candies. Oh. If it has at least 2. But the same amount of candies can't be 1. Okay, so we still need to check this inside of here. I'm curious why this one's trick or treat, though, because it's saying... I mean, technically they both got at least 2, but they don't all have the same. Okay. Regardless. They all have 2, but they... You know what? I know. Okay, so if the number of the candies in the first bag is greater than or equal to 2, and they all have the same amount of candies, then we say thank you. And then we don't have to check for at least 2. I don't think. That's the winner. Trick or treat, trick or treat, trick or treat. Okay, I think this does it. What a weird way to phrase a problem. But basically, and really we could even short circuit this. So, oh, go back. Because we'll say if the number of candies in the first bag is greater than or equal to 2, And if we all have the same amount of candies, then we're going to return, thank you, strange uncle. And now this return statement can just go outside of there. And that should still work. We've done it. Okay. Yeah, I don't think I could have done and, because if it's greater than 2 and they all have the same amount, I don't know. Okay, I don't know. Because I don't know. This seems to fix it, to solve it. I have a feeling this is not a very popular kata. It's just very strangely worded. Okay. No, we did not pass. Trick or treat needs to be a lowercase t. Okay. Attempt. We did it! Submit final. I don't want to do that one in any other way because Whoa. So they pulled out functions just like I did. At least 2 candies, same amount of candy, has a bomb. Children unhappy. So if it has a bomb, they are unhappy. Interesting. Interesting. This is actually pretty cool. You have an object with true and false properties on it, and then you have just this giant conditional, and that's either going to be true or false, but then it grabs a property from that object that's either true or false. That's pretty cool. Yeah, it's like, it's not that this one was, so the chat is saying this one was brutal for a 6Q. It's not that it was hard, it's just that it was confusing. Like, it was not very direct as to what exactly I had to do. Oh well, that was fun. On to the last one of the night, Halloween sweets. Okay. It's Halloween and you're playing trick or treat. After some hours of collecting delicious sweets, you get faced your personal challenge of the day. A house resident presents you 9 bags of sweets, and you may pick one of them. You already want to grab one of those, but then he says, if you're lucky, you get the one with an extra lollipop. An extra lollipop. The old man says, yes, I spread all sweets equally over the bags. At the end, 1 lollipop was over, so I put it randomly into one of those bags. But I don't know which of those bags it was, since they look all the same. You know you love lollipops, so you're thinking about how to find it, and in which bag the additional lollipop could be. Okay, the old man says, I have an idea. Here's a pair of scales. You can put as many bags as you want on those scale pans, and you can weigh them 2 times at most. After that, you have to decide for one of the bags. Can you find the bag that contains the extra lollipop? This is the classic problem of like 2 scales and you're trying to find the heaviest thing. Well, 1 scale, you can only use it a certain number of times. You're trying to find the heaviest thing. So here are the rules. We need to implement this function called pick, which gets passed in an array containing 9 bags. The function must return 1 bag you would pick in order to get the additional lollipop. You also get access to the scale, which provides a weigh function, and it takes in 2 parameters, something for the left scale and something for the right scale. Of course, both arrays must contain different bags, and you can only call the function 2 times at most. So we can only weigh things twice and figure it out. 8 of 9 bags can be considered to have exactly the same weight. Only the one with the extra lollipop weighs slightly more. And the result of weigh, -1 if the left is heavier, 1 if the right is heavier, or 0 if they both weigh the same thing. Cool. And it's kind of a riddle, yeah. Andrew Lane asks, how do I type MDN and search MDN? It's because I'm using DuckDuckGo. So DuckDuckGo is my default search engine, and they have what are called bang commands. So you do an exclamation mark, and they have tons of built-in services you can search. Specifically, MDN is the Mozilla Developer Network. Yeah. Okay. I actually looked up this riddle earlier. And gaming, but not really, saying this is much easier than the last one. I think the thing is, if you know how to solve the riddle, like it's fairly easy to implement in code. But let's bring the code down, and then we'll talk about it. Oh, I guess I don't really know how to test it locally. We'll write it in Code Wars. Hey Ray, welcome to the stream. Rustle says YouTube just sent me the notification. I don't know what's going on with that. Yeah, I don't know. Apologies. This was a bit of a last minute thing. Ahoy, Ron! Welcome to the stream. All right, see you later, Dan. Thanks for tuning in. Okay. Yeah, so maybe I'll pull up like the solution to this riddle, but let's think about this. Okay, so we have 9 bags, 1 scale with left and right. So the way I've heard of solving this is you split the bags up into groups of 3. So you have a group of 3, you have another group of 3, and then another group of 3. And the first way two groups. So you weigh 2 of the groups. If they weigh the same, the remaining group has the lollipop. Because we know those 2 weighed exactly the same. We know the ones over there. Okay, and this could also be like a recursive or like something that could be reused. So let's say you weigh the first 2 and they weigh the same. You can throw all of them out. Now you're left over with just 3. So second, weigh 2 of the things in the last group of 3. Okay, and if they're the same weight, then the one you didn't weigh has the lollipop in it. If same weight, remaining thing has a lollipop. Else, we know which one is the lollipop because it was heavier. Done. We only get 2 ways, 2 ways altogether. So the initial weigh is going to weigh 2 groups of 3. So we handled if they weigh the same, then it's in the remaining group. Cool. If not, the lollipop is in the heavier group. And then you would use the heavier group down here. So this logic remains the same for our second way, but the first way is just determining which group has the lollipop inside of it. Yeah, so Gaming But Not Really says, the first way will allow you to find which of the 3 groups has the extra. The second one will allow you to find the extra among the candies in the group. Yeah, it has recursion written all over it. Okay. And it may not be recursion. It could just be like a function that we can reuse and don't have to like have repetitive logic. But let's turn this into code. Okay, so we need 3 groups of 3. So group 1 is going to be, we'll do bags.slice. We want to go from 0 to 0, 1, 2 to go to 3. I think slice is non-inclusive of the last parameter. Let's see. Array.prototype.slice. End is not included, right? So if we want 0, 1, and 2 indices, we'll do that. Then we'll say go from indices 0, 1, 2, 3 to indices 6, so end at 7. So indices 3, 4, and 5, end at 6. And group 3 is going to be bags.slice. We'll go from 6 to the end. Cool. Now that we have these three groups, let's weigh groups 1 and 2 together. So how does weigh? Weigh works like this. So we'll have our result. And this is going to be scale.weigh group 1 and group 2. So if the result is equal to 0, meaning they remain the same, then let's write some function that's like final weigh. And that's going to be with group 3, because if it was 0, then the remaining group has the heavy one in it. Else, if result is equal to -1, then we'll have our final weigh with group 1, because the thing on the left. Else, final weigh with group 2. Cool. And now we need our final weigh function. Oh, I think we've lost the. No, we need to return the specific bag. Okay, we should be fine. So, final weigh takes in an array of bags, and we need to do this. We need to weigh bags at 0 and bags at 1. So I'm writing this like non-recursively and kind of like write it all out, and then we'll refactor this to make it a little bit nicer. Cool. So weigh these two, and then similar thing. So if result is equal to 0, then we know to return bags at 2, because it's going to be the last one. Else, if result is equal to -1, then we'll return bags at 0. Else, we'll return bags at 1. And that does it. And this is a function. Let's put this here. And we need to return these. Okay, this is pretty verbose. Can I clean it up? So we have 3 groups of 3. We then weigh the first 2. If they weigh the same, we know that the lollipop is in group 3. If the left one is heavier, we know that it's in group 1. If the right one is heavier, we know that it's in group 2. And then for any given set of 3 bags where we know that it contains the heaviest one, if we weigh the first and the second, if they're the same, we know that the last one has the lollipop. Otherwise, we've picked it out. I think this is it. Can anyone think of like how potentially do I make this recursive? Or how might I write this differently? So Maybe it's something like this. If bags.length is equal to 3, then we can actually just do this logic, right? Yeah. And then this can be the recursive call. I guess that's how we make it recursive, because this is now going to call it with a bag of length 3, and it'll actually return what we need it to return. We do need to pass in the scale, though. Yeah? Yeah, the number of bags is 9. Okay, I think I like this. I've been streaming for about an hour. Let's see if it works. There we go. Sample tests. Hey, it works on the sample. All right, any last thoughts? How can I do this better? I mean, I could potentially rewrite it with like some ternaries, maybe. Yarg. Yarg, mateys. Yeah, let's just do this to be fun. We're going to write it with ternaries. So, well, I don't know if we can, because we do need to hold on to the result of weighing it. JavaScript does have a switch command. Ruiz asks, how can I be like you? For starters, you have to go purchase a pirate costume. And then just grow your facial hair out, if you can do that. Yeah. Yeah, I'm just gonna stay with what I can't think of other ways to solve this. Kelly is suggesting find heavy, and you like call it within itself. I guess it's kind of what we're doing here, because this is finding the heaviest. The issue with weigh is you do need to pass in an array of arrays. So like you have to pass in an array of bags. So you can't just pass in a single bag, you have to pass in an array of one bag. Oh, we could do, so these, yeah, this if, the if else here we could turn into a switch statement. I think that's what people were suggesting. So we could do a switch on result. So if the case is 0, return bags at 2. If the case is 1, return bags at 0. If the case is 2, no, -1. Sorry, this was -1. At 1. Yeah. Not so bad. Ho 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 and a bottle of rum. Hello, Kaizen. Welcome to the stream. Really Sickness says it is nicer. Yeah, I think if your if else's ever get beyond 2 or 3, it's probably nicer to have a switch case. We could do it with an object too. Let's see what that would look like. So if we had, check this out. Oh, this is gonna get tricky. Huh? See where I'm going with this? Do have to write this in quotes, though. Well, is this gonna work? Well, we'll make it a function. I'll make this work because this is gonna look really cool, I think. Yeah, I'm gonna make it a function. What's this complaining about? I think this is valid syntax. I guess we gotta do, yeah, we gotta do this. And then you invoke it. Wow, okay, so this is an object that has 0, -1, and 1 properties in it. And then we index into the result of weighing and then invoke that specific function. And we'll do that same thing here. This one's actually going to be easier because it's not a function. Like that. Is that an extra parenthesis? Yes. This seems like less syntax. Okay, now I think we can make this even shorter. So if we did do something like this, bags.length is equal to 3. We're gonna turn this into a one-liner. Then turn this. We'll do it like this. Else, we're gonna do this. But now we can just define these in line. So if the length of the bags is 3, we do this logic. Otherwise, we break it down. Let's see if this works. This is crazy. If it works, I'm going to turn it into one line of code. Wow! Nino is saying, wow, that's a lot of code for this problem. You're already at line 81. It's because I'm writing it multiple times. Our initial solution was 25 lines long, but each one of these is a different solution. We're just writing it a different way. Okay, now let's write this all on one line. What would you do with a drunken sailor? What would you do with a drunken sailor? What would you do with a drunken sailor early in the morning? Writing things on one line is so fun. Nice, look at that. That's a good solution. One line of code. Nice. All right, I think I'm gonna submit this one and end it there. Go. Nice. 756 milliseconds. Cool. Yeah, they did a very similar thing. Oh, interesting. We've got the slicer, the picker. Weird. Yeah. I mean, if we could make this even smaller. If we let's put this into a JavaScript minifier. Oh, that's cool. It's built into DuckDuckGo. Minify. Nice. Nice. What would you do with a drunken coder? What would you do with a drunken coder? What would you do with a drunken coder early in the morning? Cool. Okay, I think I'm going to end it there. This is super fun Halloween edition of Code Wars, Code Katas. I just solved these 3, but they were pretty fun. All either pirate or Halloween themed. So thanks for participating and thanks for putting up with my ridiculousness and pirate get up. Can you hear my beads hitting each other? Cool. Yeah, that was fun. I'm glad we did this. Thanks for being here. Cool. In terms of upcoming streams, I don't know. Very, very soon. Sooner than you know it. I'm gonna start streaming more often. I'm in my 2nd week of work. Things are starting to become routine. It's not as hectic, and I do plan to start streaming more often. Ah, I like it. Christopher makes the comment, is it drunk encoder or drunken coder? Like an encoder of things? I don't know. Okay, thanks everyone for tuning in. I'll give you a yarg. What is it? Oi! Ahoy, mateys! Ahoy! Arg. Oh, hey, Sean. The stream's over, but thanks for tuning in. Cool. So, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here's this.